Okay, welcome to the video for our page 16 notes. I did start at the very bottom because we hadn't quite talked too much about compound interest yet. So I'm going to pick up just right where we left off, and then I'm going to work on the next page as well. So follow along in your notes. I am going to be highlighting things, marking things, kind of noting stuff off to the side, some things you might want to write down. Okay, first and foremost, this is about compound interest. So as we left off with, we know that compound interest, this is where you're going to make money off of your money. So if you put $500 into your bank account at the end of 1 month or a year, or how often it's compounding, you're going to make money off of that 500. If you leave it in there longer, you're going to make money off of not only the 500 that you put in originally, but the amount of money you already made previously from the bank. So we would say that this is exponential growth itself. So we've got our exponential here. So it's not linear anymore. Now we do have this big equation over here, and I like to just kind of dissect it. So I'm not a big fan of kind of cramming all of the numbers into one spot. I like to kind of play around with a little bit and then build my equation up. So one thing before we really get into this, and I think that this is where we had left off when I saw you guys, was the APR. So I think we already have this written off to the side, but just as a reminder, we do talk about APR as the annual percentage rate. Now, to be clear, annual means yearly. Okay, so that is yearly. So when we're talking about an APR, if you want to think about it in like a calendar year, then that would be starting January 1st and ending December 31st. So it's like a full year range. So 12 months. Let's see. We do months, we can do weeks, we can do quarterly, but we're going to take an entire year range. And then here we have the what the different letters in the equation mean. And I'm going to leave this for you. I'm a big fan of just doing examples so we can kind of play around with it a little bit. So if you need to flip back this page at any point in time, please do so. I'm going to go ahead and go on to our next page. And let's actually start doing some examples. So the Bob invests. All right, so let's color code some stuff here. So if Bob invests $1,200 into an account, all right, that investment for us, just in general, would be the initial amount going in. So we're going to call this A, or the initial amount. How much he puts into his account. He earns 5% annual. Okay, that means that this is going to, this 5% goes from January through December. So we have 5% annual. All right, so this is the rate at which his money is growing. It's 5%, but it is APR. All right, so January through December. All right, now things are going to change up a little bit here because we want to compound this quarterly. So compounded quarterly. All right. Nothing too crazy about this, but if you want to talk about something being done quarterly, well, you think about how many quarters you have in a year. How many quarters you have in a dollar. Well, we've got 4 quarters in a dollar. If we have 4 quarters in a dollar, then we also think we have 4 quarters in the year. So the idea of quarterly. So this quarterly is telling us 4 times per year. All right. So now we have, how much will he have in his account after? Okay, we have a couple of different time frames here. So we've got 2 years. And then, let's see, this will be when t equals 2 years, which we may have to come back and change because we're going to want it to all mesh up. And then I'll come back to the 10 years in just a minute. All right, let's start writing our equation here. So I am going to go to the percent first. So I know that he is earning 5% annually. Okay, so I want to take that 5% APR and I need to turn it into a quarterly rate. All right, so I'm going to take my 5% that is now currently from January through December. And I'm going to try to break it up into 4 even chunks. So it's for the first quarter, the second quarter, the third quarter, and the fourth quarter. So I am going to take my 5% and I'm going to divide it by 4, since 4 represents the number of quarters in a year. So number of quarters per year. All right, so if I take my 5% and I divide it by 4, I'm going to get 1.25%. This is going to be the quarterly growth rate. Okay, this is what I am going to use as my multiplier. All right, so now let's take this guy. And now you guys know, talked about this in class, whenever you make an investment, you start it with 100% of the value you're putting in. So we're starting with 100%. It does say that the money is going to be growing, so we're going to increase by this 1.25%. So we're going to go ahead and add those together. So that's going to give me 101.25%. Now, one more change I need to make. I need to be able to plug this into an equation. Well, I don't get to plug percents in. I have to turn it back into a decimal. So I'm going to grab the decimal point and slide it 2 spots to the left. So this is going to be 1.0125. And we are going to use the entire number. So I know normally I would say just go out to 3 decimal places, but we're going to go ahead and use this whole thing. You notice that this number, so this is our multiplier that we're going to put into our equation, this number is bigger than 1, which it should be. Because if our multiplier is bigger than 1, that means that it's growing. So the value is growing. All right, so we're going to use this value here, if we think about our exponential equation, as b. This is our multiplier. All right, then go back up to the initial amount, and I'm going to plug 1,200 in as like my 0th term. If I take those two guys, then I can write my equation. Well, almost. Not quite. I think we need to figure out something else. Let's think about our time frame here. If we want to, so I'm going to go back to my 2 years business. If I'm turning everything into quarterly, so my percent rate now is quarterly, my multiplier is quarterly, I need to make my time frame into quarterly. So I'm going to go back up here to my 2 years. Sorry about the noise in the background, my cat's playing. I'm going to take my 2 years and I'm going to multiply it by, well, I've got 4 quarters per year. So I'm going to do 2 years, and in each year I have 4 quarters. So if I multiply that out, that's going to give me 8 quarters. All right, now I think we're ready. So I'm going to use all of the numbers or values that I've boxed in red for the very first part. All right, so if I do 2 years, I'm going to get T of n equals my original investment, and Bob put in $1,200, times, okay, the quarterly multiplier, which is 1.0125. And since that's a quarterly multiplier, we want to do that per quarter over the time frame. So if I'm talking about 2 years, I go back to how many quarters that is, and that is 8 quarters. So I now have my equation to figure out how much money Bob's going to have after 8 quarters of compounding. So go ahead and type this in. Now, even though you guys don't necessarily have access to our graphing calculators right now, you can type this into your smartphone, or you can type it into your Chromebook. So go ahead and type this in and let's see what we get. Okay, so after typing this in, I do get a fairly long decimal, but we know this is money. So I want to make sure that I round appropriately. So I'm going to say approximately. Okay, 1325. And I'm going to go ahead and write out everything I see on my screen here. And then I'm going to go ahead and erase the parts that I don't need. Okay, so I go out to the decimals. I take a look at between the second and the third spot, because we're thinking about money. You got to be realistic here. There's no bank in existence that I'm aware of that ever rounds up for somebody, unless of course it is you paying them something. So yes, of course they're going to round up. Unfortunately though, well, it's on the flip side, they're not going to round up if they're giving you money. So we're not going to do any rounding at all in any situation like this, where you're investing money and then they give you money at the end. We're going to truncate. So we go between the second and the third after the decimal, and I'm not going to round. I am just going to chop off the rest of the numbers. It doesn't matter if the next number was a 9. They're not going to round. It's just not going to happen. So there is our answer for the 2 years. Okay, we can go back and do the same thing here, but now we need to do it for 10 years. So I'm going to go back up. Let's see if I can grab a color I haven't highlighted with yet. So for 10 years, all right, so 10 years, let's see, off to the side here. So if our time is 10 years, remember we want that to be in quarters. So we're going to do 10 times 4, because there's 4 quarters in each year, and that's going to give me 40 quarters. So I'm going to use the exact same information. I'm going to use the initial investment of 1,200. I'm going to use the multiplier of 1.0125. But now I'm going to do 40 as my exponent. So now would be a good time to pause the video, see if you can get everything plugged into the correct spot where it belongs, and then get it typed in. And then when you're ready, unpause this video or start it back up again, and then see if you and I match. Okay, here's what I got when I typed it in. You notice that the equation looks nearly identical to the red equation. The only difference is the time frame. So instead of having 8 quarters for 2 years, I now have 40 quarters for 10 years. All right, and then for my decimal, I go between the second and the third, and then I erase the rest of the guys. Okay, it looks like that's the amount of money that Bob is going to have. All right, let's move on to the last problem on this page. Go ahead and take a minute and read this to yourself, and then we'll start dissecting it. Okay, so we have that he invests or inherited. All right, so he gets $8,000. So inherited $8,000. Okay, so what I know from that then is that this is going to be A. So that's the amount of money that he starts with. So A is $8,000. Okay. He plans to invest the money, not touching it, for 15 years. Okay, 15 years is our time frame. Now, I don't know how it's compounding yet. I just know that that's my time frame. All right. So, T. Oh, that is not dark enough. Let's go to a darker green. T is 15 years. It is important to keep track of the time frames here, just because we may not be doing this yearly. Okay. Now let's see what else we got. Oh, he's got 3 options. Okay, so now let's go into these options. I think I'm just going to do one at a time. So let's do option A first. Treasury bills, 7.5% interest. Okay, it doesn't state that it's annual, but the understanding is that it is. So let's go ahead. So it's not flat out told to you. Then we're going to say that this is an APR. Okay. It is compounded monthly. All right. All right, so let's go ahead and just do this problem in blue. So we'll color code this guy here. All right, so I know that 7.5% annual compounded monthly. All right, let's fix the percent. So let's do option A here. And let's see, he's got 7.5%. That's annual. And then we want to turn it into monthly. Okay, well, there's 12 months in a year. All right, so if we divide that and do 7.5 divided by 12, that's going to give me 0.625. It's still a percent. That hasn't changed because I had 7.5%. Now I'm going to turn it into the decimal. So remember, grab the decimal point, move it 2 spots to the left. So I would have an empty spot, and then the 625. Okay, fill in the empty spots with zeros. Now we need to, oh, I think I jumped the gun actually. Let's go backwards. I think I want to include this as my rate now. I apologize. We want to do 100% plus that. Got ahead of myself. Okay, so that's going to give me 100.625%. All right, now let's go ahead and move the decimal backwards. So this is going to be 1.00625. Okay, so now this is my monthly rate. It's still bigger than 1, which tells me the money is growing, so that's good. All right, so this is going to be the B that goes into my equation. All right, let's see, monthly. Let's see if our time frame that's given to us in this question is 15 years. Okay, we know that there's 12 months per year. We've got to make sure that everything is jiving with the time frame. So this is 180 months. All right, now that's my T. Okay, I think I'm ready to write my equation now. So T of N is equal to however much money he got from his grandmother, $8,000. The multiplier that we figured out, 1.00625, and the number of months he's going to leave it in the bank. All right, let's go ahead and see how much money that gives him. So if we type that into our calculator, looks, wow, that's kind of nice. It looks like he gets 24555.61382. Double check and make sure I typed that in correctly. Yeah, I did. Okay, so let's get rid of the extra decimals at the end, because this is money. All right. So there we go. That's going to be his option A. All right, option B. All right, let's go back up. Let's color code this guy a different color. So let's go yellow. Let's see, option B. Money market account earning 6.5% annual interest. Okay, so that's 6.5% APR. And it's going to be compounded weekly. All right, so one of the things that's important to note here is that you have to know how many different like days are in a year, weeks are in a year, months are in a year, that type of stuff, quarters are in a year. So when we're talking about weeks, there are 52 weeks in a year. So let's do option B. So option B. All right, I'm going to do the exact same process here. So I've got 6.5% annual. Let's do 6.5% APR. I'm trying to turn this into weekly. So it's 52 weeks. All right, so let's do 6.5 divided by 52. So we're just kind of trying to take that percent and spread it over to weeks instead of one big chunk at a time. So this is going to be 0.125, still a percent. Okay, I'm not going to jump the gun this time. We want to add the 100 to this since the money is growing. If I add those, that's going to give me 100.125%. All right, now let's move the decimal. So that's going to give me 1.00125. All right, that is going to be my multiplier. So that is B. All right, now I need to figure out my time frame. So my time frame was still originally 15 years. So I'm going to take my 15 years and I'm going to times it by the number of weeks per year. So it's going to be 15 times 52. Which is going to give me 780. So 780 weeks. All right, that's my time frame. Now I can plug this in. So I get T of N is equal to the amount of money he got from his grandmother, 8,000, and then the multiplier that we figured out, and then how many times this money is going to make money off of itself. All right, let's go ahead and type that in. All right, so that is going to give me 21196.42794. Double check, make sure I typed it in correctly. Yep, okay, let's get rid of the extra decimals. See, that 7, you would have thought it would go up to 43 cents, but it doesn't. All right, and then we have our last scenario that we need to deal with. All right, so let's go up here. We've got option C. Let's see, a savings account earning 7% annual simple interest. Oh, okay. 7% annual simple interest. Okay, whenever I see simple interest, I am thinking immediately of y equals mx plus b. This isn't a compounding interest anymore. Compounding means that I'm going to use an exponential equation. Okay, so option C, let's put it down here. So this goes back to the example that we did on the previous page. I have to figure out what slope is. So I got to find m. That's the first thing. All right, to do that, I'm going to take the 8,000 and I'm going to times it by the 7.5%. However, I'm going to turn it out of a percent and into a decimal. So 7.5% is going to be 0.075. So that would be my multiplier. So that's going to go in here. That's telling me how much it's going to grow. All right, so now I'm going to do 8,000 times 0.075, and that's going to give me 600. All right, so there's my slope. My b in my y equals mx plus b is the amount of money he started with in the first place, which is the 8,000. Okay, so let's write this equation. So T of n is equal to mx plus b. All right, now it's annual simple interest, so we just do annually. So our time frame is still the number of years. So our time here, I believe, was 15 years that he was going to leave it in. So I'm just going to plug a 15 in here. And let's see what we get. And I don't think I have to approximate this one because I think it works out nice. I don't have to chop off any decimals. Okay, looks like 17 to 3. And no decimals. So let's go ahead and add a decimal point with a 0, 0. Double check that I typed everything in right. I think I did. Okay, so here are the 3 different options that Aaron has the opportunity to choose from. So we're going to do the calculations for him like we just did, and we're going to figure out what would be the best decision for him. Well, and that's whichever one has the most money, to be honest with you. And if I take a look at option A, option B, and option C, I think option A is the clear winner here. He gets $3,000 more than option B, and he gets almost $7,500. I guess more than $7,500 than option C. So what I would say is, based on the calculations, I would recommend option A. Just has more money.